Good afternoon, everyone. Welcome to today's Monday afternoon's lecture. Today we're going to be discussing merging our files and transactional files, which are very fun concepts. Now, please note, whatever I'm going to show you today is going to be purely theoretical. So we're going to discuss it in terms of the theory, not in terms of the actual practical application of it. So you'll see the code itself suggests that certain things will happen here, but it doesn't fully give you all the code necessary to code this out. Now, it's a good thing for you to kind of consider how it would work. For those that want a challenge, or challenge at this point in time, I'd say go and try it out. But if I were you, I'd rather focus on my test preparation for Friday. Now, for tomorrow, we will be doing a past paper in tomorrow's TUTs, early morning TUT and the afternoon TUT. So if you want to check if you're ready, if you just want to check up on something that you might be misunderstanding, please come over to the TUTs. We have semi-finalized the test. It should be a good test, I'm hoping. I hope you guys will enjoy it. All right. Other than that, few announcements. The first announcement is the fact that today was the due date for your group project. We're extending the deadline until midnight. I know there are some people that say they have some issues. So we're extending that until midnight. So please, if you're having issues, make sure you upload it. And yeah, you have until midnight. If you don't submit by midnight, then sorry, we've already extended it once. There will be no more leeway there. All right. Did I address Omar's question? All right. So how this works, only one person of the group needs to submit. So only one of your 4 or 3 members must submit the actual project, and not all 3 or all. If you're really concerned whether it's being submitted or not, I guess more than one can submit. It's not ideal. You would prefer if only one submits, but if you don't trust your team members, then I guess you can all submit. But just keep in mind, only one will be marked. Not all of them, only one of the submissions will be marked, and the others will just simply be ignored. So please, just one out of the group mark, and if you're unsure, then, well, there is an alternative. All right, now, getting to today's lecture. Today we'll be discussing transactional files and merging our files. We'll see how far we get. I don't think we'll finish completely. The session does end at, what time does the session end? At 14:30. So if I'm running over time, please just give me a warning because I can't really see my time while lecturing. But yeah. All right. So transactional files. So what we're going to start off with is transactional files, how to implement a transactional file. After that, we'll be looking at merging our files, and then how to implement merging of 2 files. I do think this will have to be pushed over into Wednesday. I don't think we'll be able to complete it. We won't be able to complete it fully today. Transactional files. So there are a few things you want to do with transactional files. So the first thing is, what do we want to be able to do with these files? So you want to be able to edit your records, delete your records, and insert records. So you want that ability to modify information you have inside your file. You want the ability to be able to remove information, and then obviously you want the ability to insert new information. Now, if you think about your sequential files, how would you do that? How would you edit a sequential file or edit a specific object in a sequential file? So the process that you most likely would think of, is the fact that you need to find the record first, read it into your memory, so have it active in your application, modify the record in memory, so modify it with your application, and then go back to the file and then change it to that file. Now, a few issues here. The first thing you'll probably think of is, how do I find this specific file first and keep my space? How do I change the information without overriding something that comes after it? And how do I store it in that specific location also without causing issues? So the problem is, of course, here is sequential files can't go back and must be reopened. It's not a situation where you can kind of keep it at one spot and be like, okay, now we're going to modify this specific spot. And if you're deleting records, once again, you'll have to find the record first. So load it in active memory, or load it into memory, have it active in your program, find the spot, and then override it with blank information, right? But in order to override it with blank information, you need to know exactly what the sizes are. Because you need to make sure that you give enough blank space or blank information in order to complete or overwrite everything. So what happens if you don't have space? What happens if you provide too much space or too little space? Not only is it corrupted information now, but it's potentially going to break your system when it reads that specific location. So read the next record to the beginning of the record to delete, override. Now you have to think back, go forward, go backwards. It's not really something you can do with sequential file. The sequential file is just reading in the items one by one from the start to the end. There's no stopping halfway through and going back. It's not something we can really look at. And then the last thing is inserting a record. Read through all the records until insert point. Okay, but where's the insert point? How are you going to find this insert point? Is it at the end of the file? Is it at a specific location? How do you determine what the insert point is going to be? So these are just a few issues if you're talking about sequential files, and if you modify, delete, or insert new information, existing information, modifying information, or removing information from the sequential files. So get something called a transactional file. Transactional file will contain a list of information that will either update, delete, and add to the sequential file, which is going to be called the master file. So transactional files are essentially a list of changes that must be applied to existing sequential files, in this case called our master file. It's a list of changes. It's a batch file of commands that need to be executed. In this case, the command is going to be update, delete, or add. Now, batch processing, application of changes following instructions in transactional file, depends on the information being listed. But there is a catch here. One catch here is the fact that both our transactional file and our master file is sorted according to their key. So the key is just an identifier to identify that specific record uniquely. And in this case, it's assumed, keep in mind, I'm saying that in this case, it's assumed that they are ordered based on their key. So they are either in numerical order or alphanumerical order or alphabetical order. And that is going to be the key thing that's going to help us to do this. If it's not in order, you will not be able to do this very easily. You'll probably have to open up a file multiple times to get the same results as what we get with an ordered file. So that's one thing I need you to keep in mind while we go through these examples. All right. Now, here you have the example of your master record, which is a student number, a name, and a mark, integer, string, and integer. Then you've got a transactional record, which is a student number, name, mark, and a transactional code. The transactional code is the command being identified, and the command being either inserting, updating, or deleting. Now, the information being provided in the transactional record is the student number, name, and mark, and the code identifies whether you're inserting this information into the master record, whether you're updating a master record, or whether you're deleting from the master record. So the information being provided is either the updated information, the new information to be inserted, or the information of the student that needs to be deleted. So 3 commands, but information that goes along with those 3 commands. So that's just the basic record structures that you need to be aware of. And we've got an example over here. In this case, we've got an example of our master file and our transactional file. And then we have a new master file. This will replace the original master file. So because we want to implement these changes from the transactional file, we'll have to create a new master file with the changes implemented there. So if you just quick glance at this, you've got the master file with 5 records in it and the transactional file with 3 records in it. And you can see in the transactional file, the first one is an insert command. So you're going to insert that into our master file. The second one is delete command. Now you can see that we have the name and the mark as a blank. The reason for that is because you only need the identifier to know which one you're going to be removing. Now you can fill it with the other information. So 08 is Bob with a mark of 18. Now you can fill it in with Bob and 18 if you want to, but all you need is just the identifier to know which one you're removing. You don't need the other information. And then the last one is an update command where you've got student 23, it's a surname or name Downs, and then the mark is being updated to 100 and compared to the master file where the mark is 23. So how would you approach this? The first thing you'll most likely do is read in or create the new master file. After that, because your two files are sorted, you start reading them one by one. So the master file you'll read, first master file is Ali. Ali is token 1, nothing to change there, so that is currently being added to the new master file. But at the same time, you're checking the transactional file to make sure that nothing is happening there. If nothing's happening there, it gets added to the new current master. Then our second situation is we read the next token. Current master record file will be 03 Beck, and then the current transactional file will be 05 Bird because 03 Beck is still before 05, which means it's being added to the master file. Then our next current master record is 08 Bob. Now 05 Bird comes before 08 Bob, which means we have 05 Bird as the new current master record to be added, which means that is being added. Once that is done, we now increase the transactional current file with the next one, which is then 08 delete, which means you're removing that specific record from the master file, the original master file, not the new one. So being removed just simply means it's not being written to the new master file. Then update the current master record, the original, to 15. And then we update the transactional current to 23. And then we see that 15 still becomes before 23. Look at the current 15, insert the current 15, and then go on to the next one. Now, we've got 23 Downs, and we've got transactional file as 23 Downs as well. We update the mark in the current file to be added to the new master, and then we simply add that to the new master. Now, you're probably sitting here thinking, okay, that actually sounds very simple compared to what you said a moment ago if it's going to be difficult. Now, looking at it visually, it looks simple, right? But have you started thinking about what you actually need to do in the code to be able to do this? So, how would this algorithm actually work? So the next few slides is a run through of the algorithm that we're taking into consideration. Please note that this is not the only way to solve it. It's one of the ways to solve it, and we're looking at it theoretically. So there's a few things left out intentionally so you can kind of apply your own mindset to how you would actually do it in code. So the first thing is you need to declare two variables. You need to declare the end of file master and the end of file transaction, which both will be false in the case of you starting to read the file. Now, before you continue, you first handle a situation where either one of these files are empty, and then you continue from there on. So you read from the master and you read from the transactional file, and the read next record is your input into your system. So what you would do next when you have a situation where you would insert information into the new master is you would handle last records in files. One of the files has a record to be processed. So what you would do is you would look at the end of file transaction. If it's not the end of the file, you'll then write the last record, read. You'll write the master file to the new master, and then check, well, not the end of file, master file, read the master file, and then write master file to the new master file. That's if you're at the end of your transactional file. Last record, read, and then write transactional file to new master file. So what you would do is you would read the transactional file and add that to the new master once the master has already been overwritten. You need to keep track of this information. It just simply cannot go over. And if you find the end of this, you need to make sure that you mark it as the end of the file, because the moment you exceed that file size, your application itself will crash. Right. Then for the third part, making sure that you're checking whether you've got the end of file for both cases, the master file and the transactional file. So if the master file is smaller than transactional file, you need to write the information over. Mr. Cottrell, sorry, can I just ask you to take over for a second? I've got the ICS people here.
Okay, but I unfortunately can't move the slides.
That's going to be fun. I'll put you on speaker. Just tell me next slide, and I'll move you to the next slide.
Okay. Any questions so far, ladies and gentlemen? Maybe go back a slide because you did cut out a few times. Mr. Van Vesthuizen, just go back a slide. Thank you. Okay. Does everyone understand what this point of this program is trying to do? Okay. Okay. That doesn't help for Jack. Okay. Okay, think about, let's just discuss where would this be used? When someone deposits money in your bank account, does it immediately reflect? Really? So if I deposit right now, it'll reflect in your account right now. It depends. Okay. Now, this is what this program is trying to do. So, my apologies. It's from the same bank, it depends on the bank, yes, I agree. But what happens is not every transaction occurs at the same time. So what happens is a bank will build up a set of transactions, money moving back and forth, credits, debits, deletes, adding, etc. Then at given points in time, they'll run these batches of instructions. And that's when the money then starts to reflect in different accounts and get removed from your account. So this is what's going on. We got our main file with our main information. Person with a mark in this case. A person with a value. Now we have transactions. Either edit, delete, or update. Oh, sorry, insert, delete, or update. Now, depending on the instruction code, we enforce one of those. So we read the first file from each file, the master file and the transaction. Now, we check what is the instruction. Is it insert, is it delete, or is it update? And does the ID number match? If the ID matches, then we apply the transaction. If the ID does not match, we read the next master file. Because the assumption is in order. We read the next master file. ID being the key. Thank you, Mr. Beck. Yes. So we read the next master file. We check based on the same key, same transaction record. We haven't moved our transaction yet. So we're still on the same master. Then we compare. If it's not the same, we read the next master and compare. Now we have this master file matching the transactional file ID, the key. So we apply the change, read the next transactional file record, check if it is equal to the ID. If it's not equal to the ID, we read the next transactional file. Okay, and we then move on to the master file, moving through the master file again. End of file transaction is initialized as. End of file transaction is just the EOF marker. Mr. van der Westhuizen is back. But do you guys get a better understanding of what's going on now? And Mr. van der Westhuizen definitely sounds better with his other microphone.
Sorry about that.
It's fine to irritate you. Okay, just go back 2 slides. So I can finish my explanation, then you can take over. Now, you see we're having master file 01 Ali. So we read that one. Then we read this transactional file 05 bird. Now, does 01 and 05 match? Is it the same record? Now, we keep reading, we keep the transactional file, we read Ali, we read Beck, we read Bob. Now, we got Bob. Is Bob greater than or less than 5? Less than, greater than. So, bird hasn't come up yet, so we can't move yet. So we look at bird, we say bird is 5, and it's an insert. So we insert number 5 into the new master file. Then we read number 8. Now, 8 matches Bob, which is also 8. And what does 8 tell us to do? What is the D telling us to do? So we delete number 8. Now we read from the master file and the transactional file, cost at 15, downs at 23. Now, again, does it match? Do 23 and 15 match? No. So we move from 15, the transactional file, which is, let's see, 23 in the transactional file. So we take 15, we move it to the new master. We still have 23 in the transactional. We read the transactional file again. For the master file again, we have 23 downs. We look at the transactional file, we have 23 downs. Now we've got the same person. What's the instructions for number 23 in the transactional file? Update. So now downs isn't 23 anymore. Downs is 100. So we update the new master file with 23 being downs 100. So the transactional file is just telling us what to do to the different people. The master file holds the information until we create our new master file. Does that make sense? Okay, cool. Then I'll hand over to Mr. van der Westhuizen.
Okay. Once again, I do apologize for that. Wonder which side of this mic is actually the correct one. Yeah. Will probably sound better with the other mic tomorrow night. So don't worry. The tutorial I'll do from home. Because I've got my proper setup there. What I'm going to do is bring my hardware into campus. Right, let's just swap over back to the slides. Right, so we have the situation of updating or deleting a transactional record. Now, this is just basically a suggestion of what the code would look like, or what you're considering. So when you look at the fact that you need to delete or update information in the master file, you would, if the transactional file is less than the master file, you are looking at additions. So if it's true that the transactional file is smaller than the master file, then it means there's no new additions. If it is bigger, then that means there are additions. So while the transaction record writes the transactional record to the new master file, if end of file transactional file, then master record read and written, end of transactional file equals true, which means you mark the end of the transactional file and go over into the end of your while loop situation. If it is true that the master file, false that your master file is larger than the transactional file, then you need to write transactional records to the new master in any case, but delete is achieved by the absence of a write, which means you don't write the transactional file to the new master. So delete is represented by the absence of taking a file from your master to your new master. That way you're deleting the information because your new file, your new master won't have that information. That's why we have these slides, to make it just a bit better to understand. And because at the top in the middle, you'll see your current master record. That's the one being tracked. Your current transaction on the right at the top is being tracked in your transactional file. At the very bottom left-hand corner, you'll see new current master, which is the current value of the item being looked at for the new master file. So that just basically explains all of these code sets. Now, working with transactional files in plain English, work with 3 files. Master file, original records must be updated. Open for reading. Transactional file, list of changes to make to the master file. Open for reading. It just refers to the fact that when we open it in our application, the only purpose for these 2 files is to read the files. We're not going to write anything to them. We're just going to read from them. The new master file is the results of applying the transactional file to the master file, replaces the original master file, so this file will be open for writing. So at the same time, you'll have all 3 files open in your application. But as you go through them one by one, the transactional files will indicate the changes you need to the new master file, and the changes will reflect in the latest master file. All right, there are some questions. So let's just go through these 2 and then I'll get to your questions. I'm assuming there will be 1 or 2. So a run through of what the algorithm does, just in simple terms. You open up the master file, you open up the transactional file, and you open up the new master file. Those are the 3 files you'll open, and in that sequence you'll open them. So you've got 3 open files. 2 for opening and reading, 1 for opening and writing. Then you'll read from the master file and you'll read from the transactional file. You'll have it in memory. It will be active. You'll prepare the master file. You'll compare the master file record against the transactional record. First process whichever record comes first and save to the new master file. So whichever information is first, whether it's in the master file or the transactional file, you'll process that and then save it to the new master file. So master file record processed, read next master file record, return to step 6. Transactional file record processed, read next transactional file record, return to step 6. Both master file record and transactional file record processed, read next master file record, read next transactional file record, return to step 6. So the idea here is that you keep on going through your master and your transactional file, checking which one is the next one to be added to the new master file. And if it's a case of an update or a delete, you'll have both of them at the same time, indicating which one is next. After which, while fetching the next record for the files, a possible 3 scenarios may occur. You reach the end of file for the master file, you close the file, process the rest of the transactional files, and then close the transactional files. You reach the end of the transactional file means you close the transactional file, and you process the rest of the master file, and then close the master file. Neither of the master file or the transaction file is finished. You keep fetching the next record from whichever file needs a new record, which is just simply step 7, explained in a more what if you find the end of that file. And that is a transactional file. So the purpose there is simply just to be able to make sure that the changes you want to make are implemented in the new file you'll be creating. So you're not updating the original file, you're creating a replacement for the file. So make sure you keep that in mind. And because everything is in memory, you can override what you have. You don't have to create a new file specifically. It's just the new master. It's the next file to take the main spot there. So you can actually keep it the same as well. Now, let's see, how much time do we have left? We have about 7 minutes left. Just want to quickly check how many slides we'll have to go through. Is it just a bit short for 7 minutes, I think. See how far we get. Right. So in this case, merging of files. The idea of merging of files is the fact that we have sequential files, multiple sequential files, and we would like to merge them all into one file. So if you take the example of a cash register, you walk into your local supermarket, you've got 10 cash registers. At the end of the day, you want to make sure everything they've done on those cash registers gets put into one file and not just kept separate, so you have everything easily at hand. So what we're going to be looking at, we still stick to our structure that we're used to, is the student number, the name, and the and at least 3 files required. So when you're merging them, you want more than 3 files. You can do it with 2 files, but that's a lot easier to manage than 3 files. 3 files, it starts getting tricky from there on out. 2 containing their own set of records open for reading, and a single file containing all of the records for the above 2 files. So read, write, if that makes sense. So if you're merging a file, you're merging from 2 files into 1 file. How does that work? So simply put, once again, you load both files into memory. So you've got file 1 at the top, file 2 at the bottom, and in the middle, you've got your third file, which is your merge file. That is going to be your final result. On the right-hand side of both file 1 and file 2, you'll see the current file that is of the current item being tracked. So if we go through this, how would this work? For file 1, we load up the first item or the first object, which is 01. And for file 2, we load up the first item, which is 03. We see that 01 will, in sort order, be before 03. So we write 01 to the merge file, and then we read the next token or the next object for file 1, so that we can compare it to file 2. We see that file 2 now contains the item that comes next in order. So we write file 2 to the merge file, and then we read the next item for file 2. And we will continue like that until we get to the end of either one of the 2 files. So we'll have 04 from file 1, you'll have 07 from file 1, and then you'll have 08 from file 2. Now, File2 will indicate that it's the end of the file as well, which means that it will indicate that it is the end of that file, and everything that remains in file1 can now be written to the merge file without having to check. So when you do these checks, make sure you have that condition to determine when is it the end of the file, so that you don't have to check every time you change the token. All right, so just going one by one, seeing which one should be placed next, and then placing that item into the new file. So straightforward, looking at the actual algorithm that you'll consider is, well, not the end of file 1 and not the end of file 2. You'll compare the two tokens, take the token that is more appropriate, put it into your file, and then read the next token. I'm saying token, I mean object. And then you'll read the next object into your active file so that you can compare it. If you have a situation where one file is empty, then you'll read that file, the rest of that file, to write the rest of that file to your new file, to your merge file. And if the other one is empty or end of the file has been achieved, you'll just simply read all of those files to your record. Right, all of those files to your record. Right, and then you've got your two end of file checks. So simple English, if you have to explain it to someone, create a sequential file 1, input the records to the correct order, in the correct order. Create sequential file 2, input the records in the correct order. Keep in mind that in order for you to merge files, in order for you to do a transactional file with a master file, you need to make sure that the objects are stored in order. If they're not in order, then these algorithms will not, will just simply break your program. And there's so many other checks that you'll have to do, which is so ineffective that you might as well just create a function, store it in order, and then read it from there. Otherwise, it's just going to be a train smash. So how the actual merging happens is open file 1, read file access, open file 2, read file access. Open file 3, create file 3 for write file access. Then read file 1 into test record 1, read file 2 into test record 2, so that you have the two records on hand. Then you simply just compare the two records. These will most likely be two arrays of records. See which one needs to be stored first, and then just simply store them into file 3. Now, there's a few ways you can do that as well. This discusses going through them one by one. Ultimately, what you can always can do as well, some of you are probably thinking about this, if we're comparing them to one another, and we're simply just merging, why don't we just create one array, store everything in the one array, and then just order the one array and then write that to the file. You can do that as well. It's simply the same thing, just in a different process. So 3 possibilities comparing records for merging. 1, record 1 is larger than 2. 2, record 2 is larger than 1. And the third possibility, the two records are equal, which means you simply just collision. Alternatively, we ignore record 2. So is it a possibility that you'll have duplicate information? If it's duplicate information, you ignore one of the two. If it's a collision, you've got the same object token or key, then you need to specify how you're going to handle that key, and you'll most likely have a rule about that, whether they'll be then listed alphabetically according to a second attribute, or whether they'll just be listed as which one was handled first. So there are different ways to handle that collision. It just depends on the information actually associated with that. And that is something you'll most likely go more in depth in testing. But like I said, it just depends on that actual information. It doesn't relate to the actual saving the file. The saving the file will still handle the same. Same thing for if you have everything on one array and you just simply order the array or sort the array in order, you'll have to manage that duplicate in any case. So you have the same situation there. All right. So over to the questions. If you have any questions, I'm going back to Blackboard now. So if you want me to look at anything specific or explain anything in more detail, I can do that for you. But just keep in mind, ultimately, these things are just discussing how you can potentially handle these two situations. One transactional file, one merging of files, where you're just simply taking the record from two different files and merging them into one file. What is the condition of the while loop of the algorithm? Okay, which one? Sorry, there's a few, and that was posted 14 minutes ago, so I'm assuming that was handled. If not, please just post more specific or more information there. Right. My question is not related to the lecture, but I would like to know if this week's lectures will also be tested in the semester test 2. No. Semester test 2 is on everything covered until last week, Thursday. So sequential files and random access files. The last work we covered that can be tested is random access files. So what time will this lecture be uploaded on Eve? I'll upload it now directly after this lecture ends. When we are merging files, can we find empty file? In this case, we assume that we don't have any empty files. Because it's sequential files, you're going to list the objects one by one. So an empty file means that you saved an empty record, so you'll just write an empty record again. But no, you wouldn't have a situation where you have an empty space or an empty file. Wait. No. Sorry, I'm thinking about an object now. I'm thinking of empty spots in the object. If you have an empty file, then all you do is you just write everything from the one file into the new file. Merging files is considering that you have two files and that you're merging them together. So if it is a case that the one file is empty, you just simply write everything from the other file into your merge file. So it's the same way of looking at the end-of file. If there is nothing inside the file, it is the end-of file, which means you just write everything else into the file. Sorry, for a moment there, I thought you were referring to an empty object, not an empty file itself. All right. So if there are any more questions, I'll be around for about 5 more minutes. We are running over time now, so I'm going to stop the recording here. Please, if you guys have any questions, ask them. We'll still be around for a while. Otherwise, you can ask them in Discord. As soon as I get home, I'll answer them as well. Discord also doesn't work on campus. Only the text, not the voice. Right. So if my sound was a bit more muffled today, I do apologize. There's crappy recording equipment in my office. All my high-end recording stuff is at home. But we are forced to come in today and for the rest of the semester. Right, but I'll see you guys tomorrow afternoon in the TUTS. Or tomorrow morning.